Given the triangle with vertices A, 4, -1, so right there, B, 5, 6, so right there, and C, 1, 3, given those 3 points, I need to show that triangle ABC is an isosceles and also a right triangle. So this is a proof using coordinate geometry. It's not a 2-column proof. It's not a flow proof or an indirect proof. I am basically using the information that I have to prove what I need to prove. So it's not going to look like the regular proofs that you're used to doing. So I need to show 2 things. Thing number 1, that this is isosceles. Isosceles means that 2 sides are congruent. So according to my picture, it looks like these would be my 2 guys. I also need to show that this is a right triangle. So according to my picture, that's the guy that would look right. So the 2 things that I need to show are that BC and CA are congruent. Since these are coordinates, I'm going to use the distance formula. The second thing I need to show is that this is a 90-degree angle. So what I'm going to do is find the slope for BC and the slope for AC and prove that they're perpendicular. Okay? And I'm going to do that again using 2 main steps. So depending on what type of teacher you have, you may need to restate the given, but I don't have to. If I was your teacher, I would just ask you to show what you need to show and explain what you're doing. So I would want you to say something to the effect of, well, number 1, and I'm showing this part first, we need to show that BC or CB is equal to AC or CA. Okay, I probably said it backwards at some point, but it all means the same thing. Now, this is coordinate geometry. So what we need to do is use the distance formula to find the length of each of these lines. And this is going to be the distance formula. Okay, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. All of that in a big square root. So it doesn't matter which one. I'll show BC first. So I will explain that BC, I need to find the distance, and the distance is a big square root. Okay, let's say that B is our 2's and C is our 1's. So if I'm doing x sub 2 minus x sub 1, that is an x. So 5 minus 1. So 5 minus 1 squared plus 6 minus 3 squared. Okay, that's going to get me 4 squared, which is a fun game, plus 3 squared in square root. Still in the square root, 16 plus 9, which is the square root of 25, which is 5. So the length of BC is 5. Now I'm going to show that AC is 5. Or what did I call it? Yep, I called it AC. So AC, the distance, is going to use the distance formula again. So let's call you my 2's and you my 1's. So let's do 4 minus 1 squared, 4 minus 1 squared, plus negative 1 minus 3 squared. That's going to equal 3 squared plus negative 4 squared. 3 squared is 9. Negative 4 in parentheses squared is 16. Looking familiar? That's going to equal 25 in the square root. And the square root of 25 is 5. Okay? So distance formula out. So I will say, because I almost stopped right there. So I will say, so BC is equal to AC using the distance formula. Might be saying too much, but why not? Why the heck not? This one won't take as long. I could use the slope formula, but I'm just going to say we need to show that BC is perpendicular to AC. I have all this space, so I'm going to use it. Slope of BC is, now let's go up here. Let's find the slope. Up 1, 2, 3 over 1, 2, 3, 4, 3 over 4. And AC is down 1, 2, 3, 4, 1, 2, 3. So negative 3 over 4. The slopes are negative reciprocals. Okay, 3 over 4. Oh, wait a minute. This is supposed to be 4 over 3. Almost ruined the whole thing. The slopes are negative reciprocals, so BC is perpendicular to AC. Since BC is equal to AC and what was the other thing? BC is perpendicular to AC. Triangle ABC is an isosceles right triangle. Ran out of space there. Okay? Probably could have written out right, but it's too late. So there you have it. Kind of a mess, but and I almost screwed things up really badly over there, but that's how it's done. You basically just show whatever math you need to show to make sure that that works. And that's it. We did it.